Most of the EV charging conversation is centered around output, but what if that's the wrong approach for some customers? In this episode, I sit down with Tim Rees from Power Innovations International to break down a different model, one that's built around reliability, right sized power, and real world deployment. We get into where the industry might be over engineering some solutions and what might actually drive uptime in the field. Let's get into it. Welcome to another episode of Field Frequency. This podcast is sponsored by Field Advantage. Field Advantage is a national IT field service company specializing in EV charging and IoT infrastructure. Today, I'm joined by Tim Rees of Power Innovations International. How you doing, Tim?
Doing well, buddy. How are you?
Doing well. Glad we got you on. Been planning to get you on for a bit of time, and glad it finally worked out for us to be able to have you on for an episode.
Yes, sir.
Want to get into who Power Innovations International is. Might abbreviate that down to PII for the remainder of this conversation so I don't trip over my words here. But I'd like to start off the conversation with you walking us through your personal origin story. Tell us what led up to you sitting in the seat that you're in today and what your role is over at Power Innovations International. And then also talk to us about PII. Tell us what PII is doing in the space, and we'll get into it.
Sounds great. Well, a way back time ago, after graduating college, I really fell into the power conversion space. So started out with working for power conversion companies, mostly power supply companies, doing a lot of AC to DC power conversion, DC to DC power conversion, anywhere from, small little wall mounts that everybody has in their house to little desktop power supplies that everybody has to, 1500-watt data center power supplies, DC conversion, and a lot of different fields. So my entire career has been in the power conversion world. I've worked for companies like CUI, Bell Power, Power One, Doorbell Electronics, just everybody that's been in the power supply, light on with a lot of the DC data center power. And I had an opportunity from a former boss of mine from a couple of different companies asked me to join Power Innovations and head up sales for the new EV charging division. And it was an easy kind of roll into this EV charging because EV charging is all power conversion. You're taking AC power in and you're putting a high voltage DC power out. So that part of it was really easy to wrap my head around. The thing moving into the charging world was, OCPP, ISO 15118. It was all of I'll say the other portions not dealing with power conversion that were kind of the hardest for me to learn and get my head wrapped around it. But after getting into it, it's communication and, making sure that that charger is up and reliable. And that's how I came into where I am today.
Well, that's a good overview. It's interesting when you talk about the conversion aspect of it. There's actually two streams of communication happening, or two streams of activity, and maybe not communication. One is obviously the electricity that's flowing. That's got to be, as you said, converted from AC to DC to charge the vehicle, and then on the communications protocol side, so you got two streams of activity happening in a charging sequence. Well, give us an overview of Power Innovations International, specifically the EV charging product line. Obviously, PII is got other power electronics and equipment and stuff, but let's talk about the EV charging line. Give us an overview of what output levels and what design. Is it a all-in-one distributed DC architecture, DC fast charging, L2? What's the product line look like?
Yep. So our product line focus right now is 30 to 60 kilowatts. So more on the smaller range, really into fleet applications and fleet applications that have dedicated routes. Think about school buses where you know exactly where they're going. They're going to come back. they've got 6 to 8 hours of dwell time. Even an 80 amp L2 might not work, perfectly, but a 30 or a 60 gets them to exactly where they want to go in charging aspect without having to put in 150 kilowatts, or they just don't need that type of power because they've got dedicated routes and dedicated dwell time. So for us, we felt like the fleet portion was something that's not really focused on. Everybody's after the 150 kilowatt and above for public charge. And the 30 and the 60 kilowatt, where fleets really is that sweet spot, we didn't feel it was really getting the attention it needed. So we have 30 to 60 kilowatt units in full stationary. The 30 kilowatt you can wall mount. 60 kilowatt is obviously a pedestal mount unit, but then we've got a mobile platform. And when I talk about mobile, it is the ability that you can take it, unplug the unit, take it to another plug, walk it around. It's still is required to have AC power, which for us is not 480 volts 3-phase. We can take single phase AC power in. We could take 208, 240 delta power in. We could take 483 phase Y power in, and we could take DC, high voltage DC power direct without an inverter stage into our units. So that's another differentiator for us that is huge, is a lot of times we can use the power you already have, not the power you wish you had. So for fleets, there's not a lot of fleet yards that have 483. So what do you have to do? You have to now buy a $10,000, $15,000, $20,000 step-up transformer to be able to operate your equipment. With ours, there's no need for that. If you've got enough 120 single phase, 208, 240 delta, or already 483 phase Y, or you've got a big BESS system, you can go directly into our chargers and get chargers in the ground and operate those chargers much quicker than taking any of the manufacturers out there that you have to have 483 phase. And mobile applications are a great where you're pushing the unit around. Everybody in the marketplace is 483 phase except Power Innovations. So you've got to have a step up transformer someplace with a unit you're trying to push around someplace or move. Kind of takes the mobility aspect out of it. But as mentioned with us, you can use that power you have that's already there. One great application for the mobile is you look at car dealerships. Car dealerships don't have 480 anywhere, but they have tons of 208 or 240 delta because you remember back in the day, they used to run all those metal halide lights that just sucked power. And now, as everybody transitioned to LED, they've got excessive amounts of 240 single phase. So, be it a mobile unit, be it a stationary unit, they can tap right into that existing 208, 240 delta and be up and charging with a mobile unit, even if it was a stationary unit, much quicker than all the competition out there. So, really, that's 30 to 60 kilowatts is where we're focusing. Fleet applications, we've actually come out with a 82 kilowatt hour battery sled that has a 30 kilowatt DC fast charger on the front of it that will slip into a 3/4 ton pickup, bright drop van, a Rivian van. As long as you have 2,000 pounds of payload capacity, you can then put this self-contained charging unit, possibly use it for fleet rescue. You think about AAA these days. What does AAA usually do? They'll bring you out a gallon, 5 gallons, 10 gallons of gas to get you down to the next. Well, this is meant to do the same thing, except with EVs. So now you're delivering 5 to 10 kilowatts, get them down to the next DC fast charger and get them back on the road again. So same kind of concept, because today in the fleet world, what happens when one of their vehicles goes down? Call a tow truck, flatbed, possibly if it's a school bus, a lowboy. How much does that cost each time that they have to go rescue a vehicle? It comes into a lot of money. So that was another aspect that we did for the fleet side, is do different things. And one of the things, I know we're going to talk about EV charging a lot on the podcast, but we can do different things with, our power conversion products. We've worked with partners that we built a hydrogen trailer, that now that power that goes to our power conversion is a hydrogen generator. So the hydrogen puts out the DC power. We use some battery buffering to get that to a stable output. That stable output then goes into our power conversion product, and we can do DC charging for vehicles, or we can do AC genset outputs. So now you look at things that everybody wants to get rid of a diesel generator, right? This can be a way to do that. You use hydrogen, and what's the output of hydrogen after you burn it? Water. So we've done different things like that to make Power Innovations not just a EV charging company. We are really truly a renewable power company. We can take any renewable input and give you DC charging on the output, or even AC genset output if needed. So very different than everybody in the industry right now today.
Yeah. Well, and if we were to unpack, you narrowed in on some of the key verticals, like the school district with a school bus fleet with a predictable fleet profile, out and back in charging. And the thought behind the design of the product is don't over engineer a solution and don't under engineer a solution. That 30 to 60 kilowatt is ideal for the school buses that have come in off the morning route. They're parked. They're getting a charge before the afternoon route, and then they're out on the day. Or maybe they get a charge again whenever they come in from the afternoon route and they've parked, school's done for the day, kids are dropped off, and they're plugging in, and they're going to get that charge all throughout. Why over engineer a solution for a charging site? And to your point, not all those parking lots that school districts have for their bus fleet have the available power needed to support traditional fueling. So that's good. And then, of course, you described mobile charging application as it applies to maybe an auto dealership. That is something I think of from back in my petroleum days. That's what we would call wet hose fueling. And that's where
Mhm.
you didn't have on-site fueling. A tanker would come in with literally a hose and would begin to dispense fuel from the small truck, not quite the big truck that they're delivering
Right.
fuel like to the gas
Yep.
stations, but they would fill up the vehicle. So cool applications, and showing the thought process behind the hardware that PII is focused on. I want to talk about design philosophy.
Mhm.
All OEMs are aiming, obviously, for reliability. They don't all design for it. And what I was hearing you say a moment ago about some of the designs that PII has within its DNA, it would seem that engineering is it's kind of just one of the basic fundamentals within what you've brought to market as far as hardware goes. So what can you talk about as it relates to PII's design philosophy? And then maybe how does PII differ from other charger manufacturers?
Yep. So you're absolutely right. I mean, from PII and Light-On's DNA as really power conversion company, we did look at it in a much different aspect than everybody else does. So if you were to take apart our 30 or our 60 kilowatt DC fast charger, what you would find is almost a mini data center power conversion in there. So we took the aspect, because Light-On is the number 2 power supply manufacturer in the world and makes tens of thousands of data center power supplies, which have to be highly reliable, because everybody, they lose their podcast, they lose their TikTok, they lose their Facebook, the world is ending. So these data center power supplies have to be very rugged, very reliable. We're talking 1 million hours between failure. So one of the big design aspects that we took was taking a 3.3 kilowatt rectifier module that's used in the data center today and changed the DC output. So we basically took what would be standard a 48, 52, possibly 60-volt data center rectifier, and we made the powertrain so it was from 250 volts up to 920 volts DC output now. So now you cover both ranges, 400 volt DC output or 800 volt DC output battery packs. So we took the same quality that Lite-On's had for 20 years, same manufacturing process, same component suppliers, same QA process. And we just built a new 3.3 kilowatt rectifier that would go into a DC fast charger, but still keep all of the design aspects, that 1 million hours MTBF. But there's other values that brought to the DC charger. So if I could show you, if we had a 60 kilowatt DC charger stack in front of us, it would actually have 6 rows of 10 3.3 kilowatt modules in it. Now, what that gives you, it gives you a full 60 kilowatt power stack, but for reliability, uptime, if you were to lose one module, that whole stack does not stop charging. You only lose 3.3 kilowatts of power. So essentially, you just lost one of the modules, but it doesn't take that whole unit down. We did that, and we made each module galvanically isolated from each other. Now, you think about, for you guys, servicing that. We lost one module. Okay, not a huge deal. You only lost 3.3 kilowatts. But for a servicing aspect, it becomes very easy to replace that module. If you've ever seen a data center rack, it's basically you got that little thumb, you pull that rectifier out, shove the old one back in. It's about a 5-minute job. So even when a power supply or a power rectifier goes down, it's very easy to replace those units. So that was another big differentiator for us is we basically got a 60 kilowatt block that is a DC charger. What else this did was give us the ability to be able to use this in different applications. Like I talked about, the hydrogen fuel cell charger. We can put it into a trailer with a BESS system. We can use it on our battery pack that I discussed as a rescue pack that takes DC input directly into the charger. Another thing we did for reliability is you, especially in the industry you've taken apart some of these chargers. You've opened up a Chempower, you've opened up a Delta, and usually when you do, you've probably got 16 to 20 filters in there someplace, kind of a spaghetti of wires, if you would. And if you look at our system inside, super clean, bus barred all the way with metal bus bars, no filters at all. So we do that by using what we call air-to-air heat exchangers. So the air-to-air heat exchangers pull air from the outside and blow it over the top of our power electronics. But it's essentially a sealed system. So there's never dirty air going across our power electronics. There's no filtering inside of our air-to-air heat exchangers. You just make sure on the outside of the DC charger that the grates are clear. So unfortunately for servicing, we don't need a lot. There's not a lot of where you have to go in every 6 months, open the unit out, change out 20 filters, blow all the mice and dirt and leaves and everything that's got caught in the unit from the time. None of that. super clean, sealed system. We even put a quick change DC cord on our unit. So if you look at the back of our power stack, you actually have just like a little Phoenix contact block, and all of our cables are pre-dressed with cable knurls on them. So you can essentially change in our 30 and our 60 kilowatt stationary units, you can change a cable in 15 minutes start to finish. So those are some of the aspects that we thought about when designing. Another aspect is installation, because if you look at our DC fast charger, you've got a certain amount that is the power block, if you would, but then there's probably down here another good amount that's just free space. And we put that free space in there thinking of the installers. All right. You've got a lot of big wires. You're coming in there and you're trying to bend, big size wires. And I don't know how many installers I've talked to that have said, "Man, your guys is just super easy. You guys thought about us having our hands in there, bending wires, trying to land it onto that bus bar." Where, they talk about, my hands look so chewed up after I tried to install one of these chargers from another manufacturer. And we tried to put all that into our design philosophy, both electrically, serviceability, reliability. Those were key factors when we were looking at designing our product and things we brought to the market. For us, big ad screens wasn't important. It was rugged reliability. What do fleets really want and what do fleets really need? And I think we hit home runs with, all of our products that are out there. You look at our mobile 30 to 50 kilowatt unit, and we got a NEMA 4 rating on that. So I don't think there's anybody out there in the mobile space that has a NEMA 4 rating on their outdoor mobile product. You can leave this thing, it gets dirty or dusty, you can actually hose it off with a hose. So just that was a really big aspect. Rugged, reliable, and make sure it's easy to service.
Yeah, it yeah, you keyed in on that from the design standpoint. It sounds like you embedded serviceability into the design itself to reduce that. So it sounds like based on the design, it's not so good for us service providers, but great for the operators. The
It
operators are
is.
glad that they don't have to call us service providers.
Correct. Or have, a 6-month servicing every 6 months that's under contract. Yes, absolutely. It's not as great for you guys, but for the operator, it's amazing because they don't have to spend that extra money to do a lot of that. And
That's
if
right.
there is an issue, you talk about truck rolls and how much time is on site. It's shortened that as well, because all you're doing is, if a power module's out, you're unplugging the top of the unit, powering down the unit, of course, but it's a 5-minute job. I mean, I've done it myself. I'm just a sales guy. I could I could change out one of these power modules in 5 minutes. So really thought about those aspects for it.
Well, in lieu of the support to the operator or the benefit value props to the operator, one of the things that you called out that listeners may not be aware of is as it relates to the cooling. A moment ago when you were talking about the cooling design, it's typically in EV charging, DC fast charging, cooling is limited to liquid cooling or kind of passive cooling. I like how you called out that it's not really either of those. You're bringing in cool air and passing it over, and then sending it back out. And so I imagine people are listening. I was like, well, how are you pulling in cold air without filters, or how are you pulling in external air without filters? Wouldn't that bring in particles and so forth into the unit? But the design is thought about that. And so we won't get into the secret sauce about how, but I
I
think
wouldn't
that's an
even know.
important.
I think it's all black magic. It's all black magic how to I know there's these little boxes that are
Yeah.
sealed and go on the
Yeah.
side, and it does its magic.
Well, we won't talk too much about it in details because your product folk might get all up in the air about sharing the
That
black
that is
magic.
Yep.
But, no, it's a cool idea and cool design because when you talk about the serviceability standpoint, I know, any asset manager is gonna be looking at not only the CapEx, but the OpEx. When you talk about OpEx from the standpoint of the serviceability, module failure, okay, the unit stays in operation and you've just lost that module. That module is swappable in a matter of minutes, and then, of course, you're derated by that kilowatts, but it's not the end of the day. And then, of course, the serviceability standpoint, those are game changers. So I like, thanks for sharing, kind of some of the ideas behind the design philosophy and operability of the unit. I'd like to kind of zoom out and look at PII and its charging products from the standpoint of kind of the marketplace and maybe get your comments around where you see other OEMs. And you alluded to it, even to the install, the large sizing of wire rather that needs to come up inside the unit and being landed on a bar somewhere, landed on a terminal block. You alluded to that. So I'd like to hear some other comments on where kind of you see the biggest disconnect between how chargers are spec'd and how they're sold, because how something is sold versus how it's actually performing and maintained in the field can be different experience for the operator, for that asset manager that's got to make sure these units are operational, especially in a fleet context.
Yeah. Yeah. And I think right now the big disconnect is there's a lot of guys that just jumped in from other fields, not the power conversion world, not, they came from different areas of the industry. And we've seen a lot of this, right? We've seen a lot of guys jump in, try to dip their toes into it, and they just fail. They don't understand the power conversion of it, and they didn't do a good job of looking at, okay, how do these go in the ground? How long, do these things need to be reliable for? And I think with our three really key points that we've looked at for the operator is that serviceability, that reliability, and just uptime hits all the buttons. And really, I'll go back to the cleanliness of our design. We put less failure points into our design to make sure it held up reliably. And I don't want to talk ill will about a lot of the other manufacturers, but when you do open up another manufacturer's product, there's a lot of different components that are spread about that unit, and each one of those different components gives you a different failure point. So we tried to reduce the number of components that go into our product, hence reduce the number of failure points. So that was a big thing for us. And I think just coming from the power conversion world, coming from our heritage of, PII started out as a UPS backup company, being bought by Lite-On in 2013, having the capability to use Lite-On factories for building our rectifiers, being able to be vertically integrated within ourself, being yes, we have access to our factories in Lite-On, which are overseas, but all of the operations for Power Innovations are integrated in North America. Our electrical design team is based out of Plano, Texas. Our firmware team is in Plano, Texas. Our operations is all out of American Fork, Utah. But we have control of all of it. So if a customer does come to us with an issue, with a vehicle, with something, we have total control to look at the firmware side of it, to look at the hardware side of it, and really be able to fix any issues right here, right in the US. So it makes that partnership so much easier because you're not waiting on having a phone call with overseas someplace. You can get to people in your time zone in the US. You have customer service issues. Our customer service is based out of Utah. So everything being North America based, we can do, and we put it this way, we can also do Build America, Buy America units. So we can do US content to get us to BABA compliance as well. And all of it right out here, the great USA.
Well, I realized an oversight on my part, so I want to take a step back. I do want to put a pin in something that you mentioned because you talked about the limiting of the components to reduce the places of failure, a failure point,
Failure
reduced.
points.
So
Yep.
I want to talk a little bit more about that in a second as it relates to durability versus cost. But one of the things I wanted to go back to that I should have asked on the beginning, you mentioned Lite-On and Lite-On's parent company to Power Innovations. Tell me how PII. Tell me what the relationship is between Lite-On. People would hear Lite-On there think, well, man, those are the L2 chargers that are out everywhere, branded
Everywhere.
this, that, and something else. So maybe really quickly for the audience, share the connection, share who Lite-On is, and share the connection to PII.
Yep. So Lite-On is, as mentioned, number two power conversion manufacturer in the world. They are also a large LED manufacturer, communications equipment manufacturer, data center power. There's a lot of facets to the Lite-On group of companies. And in
Mhm.
2013, Lite-On acquired Power Innovations for the UPS side of the business. And as most people know out there, Lite-On does make a lot of the L2 versions that are out there in the field. And I'll give you just a quick story how Power Innovations came into the L3 side of it. And part of it was our old president that ran PII, a guy by the name of Ed Carter, he'll put it, I was getting crabby with Lite-On because they weren't moving fast enough into the L3 space. And his idea, just knowing power conversion, was let's take these Lite-On data center modules, make that different powertrain, make it so it's 250 to 920 volts DC output. We can build fast chargers. And that's where Power Innovations got into the L3 game. Lite-On owns us 100%, so we are 100% under Lite-On, hence how we can get aspect to their manufacturing facility. And that was a great thing for us to be successful. We've seen in this game that a lot of people jumped into the power or into the EV charger world and had no production facilities. So they
Yeah.
had to spend billions, hundreds of millions on production facilities. And we've seen what happens to a lot of them. They couldn't survive because of that huge capex. And we didn't have to do that because we could gather all of that manufacturing of the electronic components, the power packs, if you would, from our partner, our owner, Lite-On, and it made it a really easy production run. So that's kind of the background from
Yep.
where Lite-On and PII came from and who Lite-On is.
Yeah. Well, thanks for sharing that. I probably should have called for that earlier on, but since it got brought up a couple times, I wanted to key in for those that aren't sure or aren't familiar with Lite-On. But thanks for that. And then going back to the comments around the internal product, internal components, rather, excuse me. And the reason why I want to talk about this is kind of that cost factor as it relates to hardware. There's
Mhm.
always the tension, especially in DC fast charging, always a tension around upfront cost and then the long-term durability. And you made a comment about reduced components to limit fail points. Of course, obviously you're bringing the total cost of the charger down by having less parts in it, but you're also reducing areas of failure in that charger. And so, you talked about early generation DC fast chargers. I've seen inside of them. You open them up and man, it is a smorgasbord of wires and boards and this, that, and something else. And you might need to get to a breaker, an internal breaker to replace it, but you got to remove like parts just to get to the thing you're focused on. And so that simplicity in design is one of your value propositions at PII is that
Absolutely.
that durability is there, but there's also the factor of reduced components. And so I would like to hear your comments around maybe competitors that overbuild or overdesign, or maybe you want to talk about it from the standpoint of you've brought to market a product that would appeal to the customers who are cost sensitive or limited. You talk about a fleet, especially public sector fleet that's looking to electrify. They are limited. The message to them is cost containment. And so
Absolutely.
you're probably you're probably, very competitive in terms of pricing when it comes to your hardware.
Yeah, and here's the problem that we get hit with all the time is customers look at the DC charger itself, right? Now, they don't always understand that if I don't have 480 volts coming in, that DC charger is a brick. Do anything with it. So a lot of times what happens is we are a little more expensive, than if you were to look at some of the competitions, just look at that DC charger. If you look apples to apples, we're probably a little more expensive. Now, taking that same fruit analogy is you can use our apple straight away. You can eat that apple. You can plug it into your power grid and your apple's going to work. If you don't have 483 phase, you are in it another 10, 15, 20, 30 grand for a step up transformer because that apple needs a watermelon to run, and that watermelon is a lot more expensive than just our apple over here. So it all depends on, what infrastructure do you have currently available to you? So our real cost advantage comes in at if you want to run single phase, if you want to run 208, 240 delta, 480 phase Y, I'll admit it, we're going to be a little more expensive. DC running straight DC power, we do not require an inverter stage. So you do not have to go from DC to the battery back to AC to run the charger. We can run our charger off a high voltage DC battery. So you got to look at it kind of in the big picture where a lot of people don't. They look just at the price of that DC fast charger, but they don't look at what all this other switch gear that I might need. One being that step up transformer. So that's where we have saved and can save customers 10, 15, $20,000 on their deployments. But there's also another aspect within there. You're now not installing a bunch more of that switch gear. You don't need as much permitting. You don't need as much wiring. You don't need as much trenching. You're saving time. And that all adds up to money. So that's where we get lost sometimes is people just look at the price of the charger, not the price of the overall project.
Right. And I would say those that are just factoring in on the price of the hardware probably haven't deployed many chargers because they would understand the all-in cost and not only the cost but the lead time. You're faster to a charging destination when you can use existing infrastructure. If a site doesn't have three phase, doesn't have 480 volts, and your product can work in those environments, then the path to a charging destination just got a lot faster and cheaper from an installation standpoint. You talked about the permitting, you talked about just the utility and interconnection and utility upgrades and all the stuff that goes into that, especially for a fleet that's got a bunch of vehicles that they're trying to electrify, or maybe they're trying to add to their fleet additional electrically powered vehicles. You're talking about feasibility studies, you're talking about all kinds of stuff that needs to go into building out a site. And so yeah, you can't just fixate on the price of the hardware. You got to fixate on your total cost to
Yeah.
deploy. And yeah,
Yeah.
that's good. Well,
And,
go ahead.
and the one thing that you look at right now, step up transformers can be 12 to 18 months to get. So now you've delayed your ability to get chargers in the ground by another year. And yeah, it's looking at that overall feasibility and the overall project. And we see way too many people that just focus on, well, this DC charger is $3,000 less. Yeah, it might be, but now you're going to buy a $15,000 step up transformer to run that $3,000 less DC fast charger. So I really could have just saved you 12 grand that you didn't see.
Hmm.
And a lot of that doesn't come into play a lot. And like I said, like you said, I think a lot of people that haven't deployed a lot of chargers don't look at the large infrastructure piece that goes along with it. you mentioned, the utilities themselves too. And a lot of time the utilities would rather give you a larger 240 transformer because they've got that service there than have to bring in a new 43 phase line. So even if you have 240 and you don't have enough 240, say to run enough of the chargers, you don't have enough amperage, a utility makes it easier for you to bring an existing 240 power than brand new 480 power. So all of those things need to be looked at. And I'll tell you, we're not the cheapest. You were at EVCS. You saw a lot of the, cheap stuff going out there, but they're not going to have that reliability. They're not going to have a US manufacturing company US based company behind it. And it's all, you've heard the adage, you get what you paid for.
Yes, you do. Yes, you do. Well, Tim, this has been a good conversation, and I've appreciated you coming on Field Frequency. I thank you for sharing some time and sharing some insights around Power Innovations International. For those listening that found the product compelling, want to reach out to you, want to connect to learn more about PII, where can they reach out to you? Where can they connect with you?
So LinkedIn is always a great place to reach out. Feel free to make a connection there. My email, more than happy to give out. It's Tim dot Rees at power innovations.com. Come visit our website, powerinnovations.com. There's a contact us sheet there. Love to talk to any of the guys that are looking into getting more highly reliable fleet applications going. Love to talk to you.
Right. Well, you heard it here on Field Frequency. Thank you, Tim, for sharing some time with us. It was a pleasure to have you on.
Great. Thanks, Jason. Appreciate the time, buddy.
Field Frequency is produced and edited by the team at Atozi. To find out more, visit atozi.co.